Welcome everyone to Defender for Cloud in the Field. We continue our series of episodes post-Ignite. But before I talk about what we are going to discuss today, I just want to say thanks for all the subscribers that are coming back to the show. And if you are not a subscriber yet, make sure to go to the AKA link below, hit the subscribe button, and also the bell to receive notification when new episodes are released. With that, I want to welcome back my friend Thomas Spivak for another show. Every time Thomas comes here is because there is something good, and I'm glad that he is here again. Thomas, thank you very much for being on.
Hey Yuri, it's great to be here today.
Also, my friend. So during Ignite, we released a lot of updates on containers. So I just want to start by saying thank you all for the hard work this semester to get all those features available. We released a blog post with probably 20 plus features just on containers. And we did a lot of improvements in container posture management. And when we talk about posture management, one of the main things that is part of Defender CSPM is Cloud Security Explorer, and a lot of customers are starting to get more used to Cloud Security Explorer. But to get started, can you give an overview about what really is the Security Explorer and how customers can benefit with that?
Yes, so Security Explorer is a tool that customers can use to gain full visibility to everything that happens within their environment. Basically, the way that it works, we collect everything about the customer environment in an agentless manner. So we have full inventory of what's happening in the environment, and we combine that with security information. And this basically gives complete visibility to, first of all, the full inventory that the customer have, as well as how assets interact with each other and any security insights we can provide on a customer environment.
And one of the things that I understand that happened recently was some change in the modeling of containers data that feed the secure graph to be more based on Kubernetes configuration instead of runtime state. Can you explain more a little bit about that?
Yes, of course. So basically what we did up until this recent release, we used to model the information that we see on the Kubernetes environments based on what we saw in runtime. So if there was every instance of a container, every instance of a pod, we modeled it and we represented each of those instances. Starting from this release, we changed the way that we model the data. Instead of relying on the runtime information, we're actually modeling the information based on configuration, based on the Kubernetes specification. And this basically helps us in two main ways. First of all, it enables us to provide a stable picture of what's happening on a customer environment. So we are no longer impacted by runtime. And this is aligned with the frequency that we sample the data, because it's not sampled every second. So we don't want to show any stale information. That's one aspect. And the second aspect is that it means that we are also reporting for all containers that are part of the same workload. We would always report findings just once. One example for that is the change that we did with the risk-based runtime recommendation, where instead of reporting a vulnerability for every instance of a container that is part of the workload, we only report a single vulnerability for all identical containers within the same workload.
Got it. But you also add some new data and capabilities to the secure graph, right? So what new data was added?
Correct. So we added plenty of data, starting from new security insights for containers and pods. We also expanded considerably the amount of information we collect about Kubernetes networking, which is available both for querying and when we present information either about Kubernetes services and ingresses, as well as networking information in context of workloads and their exposure to the internet. And lastly, we added a new domain, which we didn't cover up to this point, which is the Kubernetes role-based access control. So everything that is related to Kubernetes services, their binding into Kubernetes workloads, and also attack paths that are based on the Kubernetes RBAC. And we can now provide visibility to attack paths on customer environments internally within Kubernetes, from Kubernetes to the cloud environment, and from the cloud environment to Kubernetes clusters.
Now, you mentioned Secure Insights, which is a very important capability that we have across the entire Defender CSPM plan. Is really a core of the CNAP is to scan the artifacts and build the insights. So what is really part of this release when it comes to Secure Insights? What did you made available now?
Yes, so maybe I'll show that. It will be easier to follow that way. So when I'm looking at container workloads and containers, if I want to query by security insights, then we have a few new capabilities, including searching for privileged containers with privileged capabilities, containers that are using sensitive mounts, host IPC, and host PID. All of this is now queryable. Some of those insights were previously queryable when you looked at the workload level, but now it's available at all levels, whether you're looking at the workload level or the container or the pod. And of course, customers can correlate multiple insights as well as other information about the workloads when they're hunting for posture issues in their environment.
That looks great. Awesome. And thank you for sharing the screen to show this is really good, so people can see it in action. Now, even on the security insights that we are talking about, there are different types of security insights that you can obtain from the secure graph for containers network. What are some of the Kubernetes networking types that you have?
So specifically for Kubernetes networking, we've added an extended set of metadata that customers can query by, starting from service ports of ingresses and of services, and service selectors. We can now tell you which pods the services and ingresses are routing traffic from, which ingresses the services are routing traffic from, the class names that are associated with the service and the ingresses, the IPs of the load balancers that are being used, host names of ingresses, the IP of the cluster that is used to host the workloads, and the service types of the service that is being used.
Perfect. Recently, one of the things that we also did, it was the enhancement of image discovery that was added on Secure Graph. Why is this beneficial to customers?
So customers had a few pain points up until this point when they wanted to look at images. One of them was that we used to discover only images that had, we used to provide visibility only to images that we scanned for vulnerabilities. And one of the questions that customers wanted answers for is basically be able to know about those images that have not been scanned for vulnerabilities. Even though those images are not running, the fact that they are on the customer registries means that they may be used at any time. And if they are not scanned for vulnerabilities, obviously that poses a potential risk. So now using the security graph, I can specifically search for such images that have not been scanned for vulnerabilities. The way that I would perform this search, I'm starting from container images, and under security assessment, under security, I'm selecting vulnerability assessment, and now I'm specifically looking for images that have not been assessed. And basically, this gives me full visibility to all the images that have not been assessed in the environment altogether. And I can check if there is a good reason for them to exist within my environment. And if so, if not, I can action on it. This could be either because they fall out of our criteria for what should be scanned, even though they are on a supported registry. It could be because they are on an unsupported registry, and then today we don't scan them, or because they are on supported registry, but they don't meet the scan criteria. Another interesting usage is basically the ability to get full visibility to all the images in my environment. This is applicable to all the images that are registries that we support, or registries that we don't support, or if we see them at runtime, we'll still include them as part of this full inventory. Even more so is the fact that as part of the enhanced image discovery that we've added a lot of information for all the images that we are scanning. So, for example, if I'm looking at images on ACR, I can now see much more information about the image, and I can actually query about all of this information that I'm seeing. So, for example, I can see that there is a specific digest here, but say that I didn't start from the image perspective. I just started from nothing, and I want to check if I have a particular image that is being used in my environment. This is something that is very easy to check now. Basically, I go to container images, and I'm searching for images based on their digest. And here I just copied any digest that I have, and I can basically see if that image is stored on a registry. And I can also expand that query to understand if that image is not just stored on a registry, but also if it's running somewhere. So what I can do, I can add another condition to the query, use to create, and containers. And now it's not just that the image is being used somewhere on a registry. I can also tell if right now I have a running container that is using that specific image. And in this case, that's not the case, but if there were containers, I would be able to see them in here.
Fantastic. I mean, the richness of the graph is just really getting better and better. And one of the things that I noticed that we have software inventory as part of the security graph. And if you could enumerate some of the benefits of having the software inventory as part of the security graph, what would you say?
So one aspect, obviously, is the fact that I now have full software inventory of all software used within my container images and containers. That's one benefit. Another aspect is to be able to know exactly what is used on every container and container images. And I can also search for usage of specific software across my environment. To basically get to this information using the graph, I can start with container images, for example, and I can look at application, has software installed, and this will basically give me a list. It will give me all the images that are being used in my environment alongside the software that is being used on each and every image. That's one example. If I want to search for a specific software, I can do so as well. So say I want to see all the instances of images that are using OpenSSL. And this will basically return all the images that are using OpenSSL in my environment. And I can also do something more specific. Say, for example, in the case of OpenSSL, when there was the OpenSSL vulnerability for version 3, when it was originally released, there was no CVE for that vulnerability. There was just information about which versions are impacted. And obviously, if I'm looking at my vulnerability reports, I don't know yet what is the impact. Here, I can easily get an answer to that. I am basically adding another condition to this query, and I want to see all the cases where OpenSSL version 3, which was the impacted version. I want to see all occurrences where it is used. In this case, I'm going to see all the images that has OpenSSL version 3, and I can also expand that query to specifically look at running containers that are using that. And this is similar to what I showed before. And in this case, I'll be able to see not just images that are being used statically in the registry, also specifically containers that are using that. And I can, like anything with a graph, I can even narrow that down to things that are causing even greater risk to my environment. Say, for example, I don't just want to look at containers. I want to look at containers that are also exposed to the internet. And now basically I have a complete opening for attackers to go and attack my environment. Basically an attacker that has figured out how to exploit the OpenSSL vulnerability on version 3 can use the attack remotely to attack such containers. And I have an immediate action right now to take within my organization, either to close the exposure, at least close the exposure until a fix is available for this vulnerability.
That's awesome. That's super important. Thank you for that. There is another very important thing that we add, which is Kubernetes RBAC. This is now available on the secure graph. So explain a little bit more about how customer can benefit of having this insight as part of the secure graph.
So there are multiple benefits to the fact that Kubernetes RBAC is now part of the security graph. The first is visibility. Security practitioners are not always experts in the world of Kubernetes, and they don't always know about all their clusters. They don't have the required permissions to query the clusters. All of this makes it very hard to understand the permissions that are actually given within within the organization's Kubernetes clusters. Using the security graph, it's now very easy to actually gain visibility to that, starting from service accounts. So going to identity and access, I can specifically select Kubernetes service accounts. And this basically gives me visibility to all the service accounts that exist within my environment. Taking the next step, I can actually see the exact permissions that each one of those service accounts has and what it has permissions to. So in this case, I'm selecting Kubernetes clusters and Kubernetes namespaces. And now I gain visibility to the specific permission that each of those service accounts has. In this example, for example, we're looking at admin service account, and we can see that this admin service account basically have full permissions to perform anything on the cluster level. Maybe this is indeed something that I need in my environment, or maybe this is over-provisioning of permissions. And the fact that I have visibility to that means that I can start look into that and understand whether those permissions are justified. Second, when I'm looking at Kubernetes workloads, So I'm just starting this query from start. I'm going into containers. I'm selecting Kubernetes workloads. And now I can see not just service accounts, but I can actually see which service accounts are associated with which Kubernetes workloads. And based on that, I can also see the permissions that they have. This could be internally within Kubernetes, or this is also relevant for other resources that are used in the cloud. So in this case, I'm selecting everything. And in this case, once this query returns, I'll be able to see for each one of the workloads, the type of permissions it has within Kubernetes or outside Kubernetes. And I basically have full visibility to that. The next aspect, which is, I'd said, probably the most interesting for customers, because as long as I am on Defender CSPM, I don't need to take any action. I'll get immediate visibility to attack paths that an attacker can take advantage of, either internally within Kubernetes or from Kubernetes to the cloud, or from the cloud to Kubernetes. For example, if I'm looking at attack path analysis, and I'll specifically focus on containers, just so we can quickly see relevant attack paths. So as resource type, I'm going to select container. And let's look, for example, at the attack path that has the highest critical level for containers. What we can see here is that we have a container, and that container has a vulnerability, and it's also exposed to the internet. It's also using the host network, and not just that, but that container also can authenticate as a managed identity. And that managed identity happened to have access permissions into a storage account outside Kubernetes that is part of my cloud environment. And that storage account also happens to be a critical storage account, so it will have especially sensitive data for my organization. And an attacker can basically take advantage of this path to attack me at any time. There is a vulnerability here that can be remotely exploited, which is part of this image that is used for this container. An attacker can connect from the internet, take advantage of this vulnerability remotely, use the identity that is associated with this container to perform lateral movement, access the storage account, and exfiltrate sensitive information from the organization.
Well, I have one last question. I mean, this episode has been amazing because we are alternating between demo all the time, so I think it's super dynamic. But there is one question related to critical asset protection capabilities. What did we introduce with this new release?
We expanded the ability. We expanded the critical asset protection rules with two type of new rules. First of all, we've given customers the ability to indicate that create rules that would automatically indicate to Defender for Cloud that the workloads are critical, either based on the namespace that is associated with the workload or labels that are associated with the workload. That's one aspect. And the second one is that we are now providing out of the box criticality rules for Kubernetes clusters that basically helps customers automatically helps us automatically understand that there are Kubernetes clusters within a customer environment that are critical to the organization and should be prioritized both when evaluating risk for recommendations, as well as when calculating attack paths, and it's also available for customers to query on using the security graph. Then this way I can basically find all the Kubernetes clusters that are tagged as critical in my organization. And of course, I can also add additional, more granular setting to that and specifically find them based on their criticality level. And I can also see that this is something that is reflected within attack paths and recommendations. So for example, if I'm specifically looking at attack paths where the target is a Kubernetes cluster, then in this case, we can see that now I have, we mentioned before that I can perform a lateral movement from a Kubernetes workload to Kubernetes. In this case, I have a container that is exposed to the internet and also uses an image with a vulnerability that can be remotely exploited. And this specific container can authenticate as a service account that has access to a Kubernetes cluster that is critical. And obviously, this means that if an attacker use this attack path, they would be able to attack not only the application that is directly exposed to the internet, they'll basically be able to jump from here to the cluster and impact all of the applications that are running within this cluster, which is also critical to the organization.
Tomar, this was extremely good episode with all these capabilities, because it's not only about talking about the capability itself and documenting it, that we do have documentation available for that, but really making the correlation of how this new capability is going to help customers. And I think that you were able to convey that and bridge this gap between understanding the feature and the usability of the feature. So thank you very much for your time and for putting this together.
Thank you, Yuri.
I do have one last question. Because I think that's probably one of the most important one, actually. To have all this, customers do need Defender for containers, or this is all part of Defender CSPM, which brings container posture management?
So all the capabilities that I mentioned, except one, are available both in Defender for containers and Defender CSPM. The security graph is available in Defender for containers as well. So everything that is related to actively searching for posture issues is also available in Defender for Container. The Security Explorer and all the queries that I showed will be available in Defender for Containers. The new modeling that we did, of course, will also be available within the Defender for Containers, and it's also reflected in the risk-based vulnerability assessment recommendations. The only aspect that is not available in Defender for Containers is attack paths, which is only available via Defender CSPM.
So just to double check and clarify, if I have only Defender CSPM, I do not have Defender for Containers, I do not get all those insights?
If you have Defender CSPM, you are getting all the capabilities that we discussed during this session today.
Okay, perfect. That's exactly what I need to clarify. And I'm pretty sure that the audience will appreciate that. Well, Tom, thank you very much again for being on and bring all that information.
No problem. Thank you very much, Yuri, for having me.
Absolutely. All right, everyone. That's a wrap for today's episode. Amazing one. There are other ones that are really good too that are lined up to talk about post-Ignite. There is actually more episodes coming up about containers. So stay tuned. Subscribe to our playlist at Microsoft Security Channel, and see you again next time.